Hello and welcome to a new episode of the Data Science Daily Series. And today we are going to talk about operations on some ordered data structures within Python. Today is going to be a very interesting session because it's going to be very interesting data structures that we are going to be talking about. So without further ado, let's get started and dive right into the session. All right. Okay, so as always, you will find this particular notebook's PDF file in the comments. So make sure you're going through that after the video or even as you're watching the video as well. So the first cell that I am executing here, right, it's basically just increasing the width to 100%. So that makes it easy for me to actually, see what is there written in the different cells. So just run this. Don't worry about what these first two lines of code are doing. These are basically expanding the width of the Jupyter cells to 100%. All right. Now let's come to today's main agenda. So we will be talking about lists and tuples. And these are the fundamental data structures in Python used to store collections of items. While they share some functionalities, the key difference, as you might recall from our initial data types in Python sessions, is that one is mutable, the other one is not. Can you think which one is mutable? That's list. Lists are mutable, while tuples are immutable. That is, they are fixed once created. Right? That's the meaning of immutable. Today's overview, basically, we will look at the common operations, where some operations are common in both lists and tuples, whereas others are only specific to lists just because they are mutable, and tuples are immutable, so you cannot perform those same operations on tuples, and we will shortly see what those operations are. Now let's have a quick recap. Lists are used to store multiple items in a given variable. These are mutable and ordered collections of data. So this is how we define a list. Remember, we use square brackets. All right. So this list has three elements, 10, 20, and 30. These three numbers or integers, basically, to be precise. And I'm just returning this onto the console. And this is what it's looking like. I'm creating another list, my list 2, right, which has another set of three elements. Two of them are strings. This is also possible, right? This list can hold elements of different data types. Or lists can also hold lists within themselves. So that's something called a nested list, where you have a list within a list. So here the first element of this my_list_3 is a list itself, right? Which is actually the first list in terms of the elements, 10, 20, 30. So this is also possible to nest lists within lists or nest tuples within lists, right? We can also do that. All right. Coming to tuples, tuples are similar to lists. They are used to store multiple items in a single variable. But these are immutable, that they cannot be changed once created, and they are also an ordered collection of data, meaning that we can index them, and we will shortly see how. Remember, these use parentheses, and again, these can be nested, like my_tuple_2. All right. Now let's look at accessing elements, and let's look at this particular section. So in accessing elements, remember we talked about two things when we were talking about operations on strings: indexing and slicing. So indexing is about retrieving elements using their position within the sequence. Both lists and tuples use zero-based indexing. Even in Python, zero-based indexing is the most common, meaning that the first element is at index 0. Slicing is the second operation for accessing elements. It helps us extract a subsequence of elements using a colon notation. Right? You can specify the start, stop, and the step indices to customize the extraction. Remember, the start index is always included, but the stop index is not included. That is, that value which is there at the stop index is not returned, and we will shortly see this. Let's look at indexing on lists first, right? So my list 3 is this, and I want to extract the number 30 from the list. So remember, this first element is actually a list, but this is the first element, right? The first element is the list, which is containing 3 elements in itself, right? The second element of this larger outer list is hello, and the third element is 50. So to index the first element, we need to index it with the 0th index, right? And then once we index it, right, we get this inner list. And within this inner list, we can see that 30 is lying in the third element, which is the second index. So you have to go one step further and press and enter the second index to extract it. All right. Coming to one more example, my list 4, right? It is all numbers. Now we want to slice it and we want to find out all the values after the first occurrence of the number 100. So after this 100 comes in, what are the values? So let's say you go manually, you see this is the 0th index, this is the first index, the second index, third index. So I want to take values after 4th index. So what you can do is you can simply mention my list 4 and then index it with 4 colon and leave the stop index to be blank, right? So Python will automatically understand that you want to stop till the end. You want to take everything till the end. You don't need to mention the end index at all. Because if you mention the end index, remember, it will not be taken, right? So in this case, this is 4, this is 5, this is 6. Right now it is returning till 250, but if I mention 6, it will only return till 210, the second last element. So there's no way for you to actually mention that, I want till the end. If you just leave it blank, the stop index, it will automatically understand. And you can get the last two values. You can use a negative index as well, like -2 colon, and it will give you the last two values. Remember, this is a negative index. The last element is -1, the second last element is -2, and so on. You're going reverse. All right, same thing on tuples, right? You can index on tuples, right? You have this my_top_3. You want to extract 30. Now remember here, the second element is having this list in the tuple, right? The second element is the list. So first you index it that way. You get this inner list, and then in that inner list, the second element is 30. The third element is 30. So that is the second index, and you get 30. All right, taking another example, similarly, you can slice it. So if you wanted to use after 100, right, you see that the 100 is the fourth element of the third index. And then basically you want to go from the fourth index forward. And similarly for the negative indexing. Okay, let's look at some list specific operations now. Let me collapse this and uncollapse or expand this. List specific operations, and these are very specific to lists. They cannot be applied on tuples because lists are mutable and tuples are immutable. That means tuples cannot be changed once created. The add element function, which is the append function, this helps us add an element to the end of the list. So if this is my list, right, which is 10, 20, 30, and I want to append a tuple to it towards the end, right? So tuple will act as one element in the list towards the end. So the last element should become a tuple, is what I'm saying. What I will do is I will say my_list dot append, right? And dot append will basically open up a bracket and it'll also have a closing bracket. Within that, I want to have a tuple. So I have to mention another bracket of a tuple, mention the tuple itself, and then close it, right? So this is my tuple. The inner argument, right, of the append function is the tuple. And if I do this, note that this is not returning anything. And we discussed that whenever there is an operation that changes the underlying variable or the object itself, we will call it out. So this is one of them, and there are multiple of these in lists specifically. Dot append will change the underlying list. Okay, so it's not printing anything, but it's changing my_list, and you will see that my list has now changed. The last element is a tuple, right? So this is the dot append method, or you can call it a function as well, which basically adds an element to the end of the list. Now let's say you don't want to add it to the end, you want to make it somewhere in the beginning, or somewhere in the middle. So what you need to do is you need to use the insert method instead. Mention the index where you want to insert the element, and then mention the element value as well. So let's say in this list now, my_list, which is this with 4 elements, I want to insert, let's say at the first index, or first index is basically, it should be the second element in the list, right? I want to insert hello. So what I will do is I will say my_list dot insert. I will mention the index number, which is 1, comma, the value of the element, which is hello, and it will insert it. Again, it will change the underlying list. And you will see that, this list now has hello as the second element. So this is the power of the insert function or the insert method. Now, let's say you don't want to append elements, you don't want to insert elements, you have multiple lists and you just want to combine them all into one. How do you do that, right? Or let's say you don't have a multiple set of lists or multiple lists, you have one list and one tuple. So you want to add the elements from the tuple to the list. How will that work? All right, so let's look at this. My underscore list 2 is this, right? And what I want to do is I want to extend this my underscore list variable, this one which is highlighted, with the elements of my underscore list underscore 2. So I can simply call my underscore list dot extend my underscore list underscore 2, and all the elements of this inner list, which is there in, which is the argument of this extend function, will be appended towards the end in the same order. Remember, it's an ordered collection, so everything will be in the same order to the main list, the list which is basically having this extend function called upon. So if you run this, you will see that hello, all lowercase 2 and the string 5.1 have been added. Now I also said that it can also happen for a tuple, right? All the tuples are immutable, lists are not. So you can also extend a list with a tuple. You can also extend a list with a tuples elements. Let's see how it works. If I do this, my list will now have 10, 20, 30 in the end, right? Very interesting. Okay, make sure you are grasping this completely before moving forward. Now we've added elements. Let me collapse this. Now how do you remove elements? Now you can use something called the remove method, which removes the first occurrence of a specific value. Remember, it removes the first occurrence, it doesn't remove all the occurrences, and it also changes the underlying list itself. So my list initially has 1, 2, right? So if I say remove 1, 2, right, it will remove it, right? And it's not printing anything when I'm calling remove, so nothing is getting printed, but it is still changing the underlying object. And that's how remove works. So you need to remember this, which methods in Python specifically change the underlying variable automatically and which ones do not. That is, you need to assign them to a new variable again in order for it to work. So my list is now not having this tuple anymore. Now also notice that if I do dot remove 10, it will only remove the first occurrence of 10. It will not remove all the 10s. So it has removed the first occurrence, but this second occurrence still remains. So this is an example where remove function only removes the first occurrence of the element mentioned, right? So remove element, this will make it clear. All right, so this is the remove method. Now there's another method which basically says that you don't need to know the value, you need to know the index at which you want to remove the value. So pop is that function which removes and returns the element at the specific index that is basically removed from the list. So if I say my list.pop and give it an argument 4, that means the fourth index I want to remove, right? I want to remove the fourth element. Now here, what is the fourth element of the list? The fourth element is the all lowercase hello, right? Now if I do pop 4, it will remove that, but it will also return it. Sorry, the fourth index is 2, right? So this is the 0th index, which is the first element. Second element is 20, which is the first index. Second index is 30. Fourth index is hello, and fifth index is 2. So sorry, again, this is 0, 1, 2, 3, 4, right? So 2 is the fourth index, and I'm removing 4 here, fourth index here. That's why it is returning me 2. And I can also assign this particular value to a variable. So because it is returning 2, right? If I want to save what have I popped, I can store it like, let's say variable 1 or var1 is equal to mylist.pop4, right? And it will save that for me. So let's see this new list now, and let's take that example. Now remember, the fourth index element has been removed, which is 2 has been removed. So this is our new list. Now let's say I again call mylist.pop4. Now what is the fourth index here? Fourth index is 5.1, which is the string. And let's say I assign it to a temporary variable, and I print the temporary variable. Now the temporary variable that I have kind of returned on the console is 5.1. But if you see my list still has 5.1 removed. So it is, pop is removing it, but it is also returning it. So if you want to keep a track of what have you popped or what have you removed, pop is a good function. If you don't want that functionality, okay, before that, if you don't mention anything within pop, right, it removes the last element by default. So here the last element is 30, and it will return the value. So it will remove 30, and it has returned the value here. And if you see the list again, it has removed 30. So this is about the pop method. And very similar to pop, there is the delete method or the del method, where you need to mention which element you want to remove. It removes it, but it doesn't return anything basically. That's the main difference between pop and delete. So if you want to remove the first element, which is this hello string, right? If I do del spacebar my list and then the 0th index, it will basically remove that from the list. So you will see that hello has been removed from the list, and you only have 20, 30, all lowercase hello, 20, 20, 10, 20, right? All right, so this is about common operations on lists, which are specific to lists. Now let's look at some common operations for both lists and tuples, and very, very simple operations. These are very, very widely used, so make sure you are understanding this. First one is length. Find the number of elements using the len function. So my list is this, let's say, right? And I want to find the length of this. Now, what should be the length, right? If you see the elements that you can see, the data that is there, there is 10, 100, 20, 30, hello, 50. The length will not be 6. Why? Because, let me zoom this further in. Because the number of elements within this outer list, right? There is one inner list, which also has a tuple within it. That doesn't matter, right? Because this is a list in itself. So this is one element, this counted as one element. Then this is the second element, hello, and the third element is 50. So if you take the length of the list, it is 3, right? And let's see the similar example for the tuple. So what we will do for understanding the length of the tuple is we will extract this inner tuple. So remember, this is the first list, or the first element is this list. So I need to get this first, and within this inner list, the first element is this tuple. So I need to get that. So 0 and 0, right? If I index it twice with 0 and 0, I will get this tuple as the output. And now I will apply the same len function on this tuple just to demonstrate that it works also on tuples. And I'm getting the value of 2, right? So this is the length operation. The next operation is the membership operation. Check if an element exists using the in operator. So my list 5 is basically this. Is 10 in my list 5, right? So if you would see this, you would think that, okay, 10 is there, but it's not there actually, because the first element is a list itself. Unless you say that, this is a complete list. Think of it as one object. You cannot demarcate that and say that, okay, it also has 10 within it. No, you only have the first element is a list, right? Nothing doing what is within it. Second one is hello, third one is 50. So 10 is not in my list 5. That's why it's returning false, right? Is 50 in my list 5? 50 is there. That's why it is returning true. So it's a statement, and it will return a boolean basically. And for tuple also same holds, right? So here I'm saying is hello in this tuple, and it's returning true. Now note that what is outside what is the first part of the expression It is in single quotes, but within the tuple, hello is in double quotations, and that doesn't matter. Both are strings and both are equivalent to each other, right? Very subtle point, but something to keep in mind. Now let's look at concatenation. You can combine two sequences. This works for both tuples and lists. Why it works for tuples? Because you're not mutating the existing tuple. You're creating a new kind of a value or variable, right? So let's look at for list first. So this is my list. This is my list 2. If you add it, it becomes basically, it appends the elements of the second list in an ordered manner to the first list, right? Similar to extend basically. But for tuple, let's look at extend once again, right? Extend actually changes the inherent variable itself, right? But that's not what's happening when you're using plus. Plus will not change anything inherently. So that's the main difference. Where is it? Yeah. Actually, that's the main difference. It's kind of like extend, but it's not changing the underlying variable. That's how it's different. And that's why it also works for tuple, because it doesn't change anything underlying. This is my tuple, and this is my tuple 2. If you add it, it will basically just append it, right? And it will create a new tuple. But the underlying tuples are not changing. They are not mutating, right? So they are still immutable. But you can still add it, and you can create a new variable or a new object as such, right? Here we have not defined that new object. We have not assigned the variable, but you can do it. Remember, and also see that you cannot remove an element like -1. So you might be thinking that plus works, so why not minus? If I want to remove a tuple which is -1, will it remove, like, let's say this element, or 10 for example? Will it work? It will not work. Minus doesn't work, right? Plus will work. If I do plus, it will return my tuple. Okay, yeah. So if I do plus 20, it will work, right? Okay, so this minus doesn't exist, but plus exists. Okay. Minimum and maximum. You can find the smallest and largest elements using min and max. So this is my list 4, right? It only works on collections of items or lists and tuples which only have numbers, right? So if I have a list like this, if I do min, it will give me the minimum value. Max will give me the maximum value. Similarly for tuple also it works. And lastly, for lastly, for counting, basically, let's say you have my list 6, which has all of these elements. I want to find out how many times or the number of occurrences of one particular element. So I need to mention the value of that. So 1 here is the value. My list 6 dot count 1. It will tell me the number of occurrences of 1 in the entire list. That is 4, right? And let's look at another example, which is my top 6. Here I have the first element as a list of ones, and I have a lot of other elements. If I want to count the number of ones, remember, again, it will not count the ones within this list. This list is one black box object. What is within it is not counted at all, right? So what it will count is these 3 and then last 3. So it will give us 6. All right. Okay. And then we come to sorting. Now, sorting will basically arrange the elements from smallest to largest in an ascending order, right? And you can do it using 2 methods, the dot sort method or the sorted method. There's a slight difference. The main difference is that between sort and sorted is how you perform the sortings, right? If you use sort, it will modify the existing list in place, right? So it will basically change the underlying object, whereas you can call sorted as a function, right? Not as a method. You cannot say that my list 6 dot sorted. That will not work. My list 6 dot sort will work, right? But sorted needs to be called in the beginning. It's a function. It creates a new sorted output, right? That's why sorted works on tuples, right? And sort doesn't work on tuples. Let's see this by an example, right? That will become very clear. So this is my list 6. And if I call my list 6 dot sort, it will change the variable in place, and note nothing is printed, and my list 6 becomes this. So you can see that the 3s and the 4s have been ordered now, right? Now let me create one more tuple variable, right? My tup7, and this is what that variable is. If I again try to call dot sort on it, it will not work because tuples are immutable and they don't have this attribute at all called sort. However, if I call sorted as a function, now note that sorted is called in the beginning. Sorted brackets mytup7. It is returning a new object. It is not changing mytup7 at all. So if I do sorted mytup7, it will return me a sorted list now. What it is returning is a list, right? So this always sorted always returns a list by default, even when acting upon a tuple, right? It will return a list, but notice that it doesn't change the underlying tuple at all, right? And we can also do the same on my list 6, and it will also sort it, right? All right, so this is it for today. Remember one last thing, that tuples, due to their immutability, cannot be modified using methods like append or insert or extend. They excel in situations where data integrity is crucial. You have a large code base and you want to keep that integrity of that data intact, then you will use tuples. So we covered a lot of ground today, and we talked about a quick recap. We talked about accessing elements for both tuples and lists. Talked about some list specific operations, mainly like adding and removing elements, because lists are mutable, tuples are not. So this doesn't apply for tuples. And then we looked at some common operations for both lists and tuples. As always, if you have any questions, feel free to put them in the chat. I will get back to you as soon as possible. Hope you enjoyed the session. See you tomorrow.